Hi everyone, we're going to look at how to solve a system of linear equations here using the substitution method. So what that means is we're going to substitute one equation into the other one to get rid of a variable and allow us to solve for the other variable. So if you see here, the first one is pretty nice for substitution because we've got something equaling x. This 5y plus 60 equals x. So what we're going to do is we're going to substitute this whole thing into where x is in the other equation. Since it equals x, we can replace the x in the other equation with this whole thing in parentheses. So we're going to do 3 times the x thing plus 1y equaling 20, because it was 3x plus 1y is 20. But now we're saying don't call it x, call the thing that equals x, 5y plus 60. That's going to go in for x, since it's substituting in, we're replacing in something that is equal to x. Then we're going to simply solve this equation for y, because we've got just y's left. We're going to distribute in, we're going to get 15y plus 180, plus 1y equals 20. The 1y is still there. Then we're going to combine like terms. We're going to get 16y's plus 180 equaling 20. Then we're going to solve a nice little two-step equation. We're not going to touch the variable first. We're going to move the positive 180 by subtracting. We're going to get a negative 160 equaling 16y. Then we're going to divide by the constant, or the coefficient of 16. And we get our y value, which is negative 10. Like with any other system, this is not done until we find the x that goes with the y. And we want to find the easier equation to work with. Now, if you look at the first equation, it says x equals. That's going to be pretty easy to find x because it says x equals. So we're going to do x equals 5 times the y plus 10. Or plus 60, I'm sorry. The y is negative 10. And now we're going to use this to find the x coordinates. So 5 times negative 10 is negative 50 plus 60. And our x is actually positive 10. So our answer now is the x coordinate with the y coordinate as a coordinate point, so it's 10, negative 10. Now, a different way to do this, if we've got it where both are equal to y, or equal to any letter in whatever case we've got, is we can actually take one and plug it in just like it did before, but it looks a little bit different. So say we've got 5y plus 7 equals y, 5x plus 7 equals y. We can take this and we can plug this in for y in the other equation. So that 5x plus 7 is going to go in for y right here. It's the same idea. We're just going to swap this in and substitute in order to solve for x. So 5x plus 7 equals negative 6x minus 70. So we've essentially set the two equations equal to each other since they were both equal to y. This one was y and this one was y, so we set them equal. Then we just solve for x. I'm going to move the smaller x's here by doing plus 6x plus 6x. So 11x plus 7 equals negative 70. Look at that, we've got another two-step. So we're going to subtract 7 from both sides to get rid of our constant. Negative 77 equals 11x. Dividing by our coefficient gives us x equals negative 7. And of course, we're not done, we've got to find the y. Either one you use should give you the same answer. I'm going to use the first one, less negatives, usually easier to do in my head. So 5 times the x coordinate plus 7, so negative 35 plus 7. So our y coordinate is going to be negative 28. Write it as a coordinate point, negative 7, negative 28, since it is x and y, and we are done.